Hey guys, today we are going to be looking at proportionality and linear relationships. So let's start with proportional relationships. These are multiplicative relationships that are going to go through the origin. So you are just going to multiply your input by a certain number and get your output. This k is a constant of proportionality, or the rate of change. It can be found by doing y over x, and it's that constant multiplier. So let's look at number 1. It says the table shows the total cost for purchasing different numbers of tickets at a movie theater. What is the constant of proportionality? That relates to y, the total cost in dollars, to x, the number of tickets purchased. So since they're asking for the constant of proportionality, I know I can just do y divided by x to find that. So to find k, the constant of proportionality, I will pick an ordered pair from the table to do y divided by x with. I'm just going to choose the first one. So k, my constant of proportionality, will be 45 divided by 3, which is 15. So the total cost in dollars to purchase a ticket is $15. Number 2 says that the cost of 4 pounds of mangoes is $8.60. What is the constant of proportionality that relates cost in dollars, y, to the number of pounds of mangoes, x? So again, since they are asking for that constant of proportionality, I know I can find k by doing y divided by x. And they told me what y and x represent here. Y is the cost in dollars, and x is the pounds of mango. So I can set up a ratio like that. It told me it was $8.60, that's y, for 4 pounds of mangoes. And now I just need to do $8.60 divided by 4. And I get $2.15 for 1 pound of mangoes. Okay, number 3 says, based on the graph, how many calories does a person burn after 18 push-ups or after 1 push-up? So I just need to analyze the graph for these specific points. So push-ups is on the x-axis, so let's start with 18 push-ups. 18 push-ups is right here, and my line is showing me that if someone has done 18 push-ups, they have burned 6 calories. And then if they have done 1 push-up, well, I can't really see that on the graph, but let's take, because 1 is right here and I have no idea what that is on the graph there. So let's take this information that I just found, 18 push-ups is 6 calories, to figure out how much 1 push-up will burn. So I'm going to take the calories burned, the y, 6, and divide it by 18. Both of those numbers are divisible by 6. 6 divided by 6 is 1, and 18 divided by 6 is 3. So it would burn 1/3 of a calorie for 1 push-up. Okay, number 4 says, which of these does not represent the distance a train travels when going 40 miles per hour? So we are looking for one that is not going to represent that. So A says D equals 40t, where D represents the distance in miles and T represents the time in hours. So that one would represent 40 miles per hour because you'd be multiplying the time in hours by 40 to get that distance. So this is not going to be my answer. B says in 4 hours the train will travel a distance of 120 miles. Well, let's figure out how many miles per hour that would be by doing 120 divided by 4, and I get 30 miles per hour. So that does not match the 40 miles per hour, so this is my answer. So let's make sure this last table is showing the 40 miles per hour and that we selected the right one as B, not representing the 40 miles per hour. So I'm going to figure out the constant of proportionality for this table by doing y divided by x, miles divided by hours for each of the ordered pairs, and making sure it is 40. So this first one is 200 divided by 5, which is 40. This next one is 280 divided by 7, which is 40. And then the last one is 360 divided by 9, which is 40 as well. So A and C do show 40 miles per hour. B is the one that does not show 40 miles per hour. So those were all proportional relationships. They went through the origin and they had that constant of proportionality or rate of change by doing y divided by x. Non-proportional relationships, instead of having that multiplicative relationship, they're going to have an additive relationship, and they're not going to start at 0. And they're going to be written in the form y equals mx plus b, where x is your input or independent and y is your output or dependent. They're still going to have a rate of change, but it's not going to be the constant multiplier, it's going to be the constant addition. And you would find it by doing the change in y divided by the change in x. And then b is the y-intercept, which is where x is 0. It is the constant in the equation or the starting value. So let's look at number 5. It says, Jeremy started a toy car collection. His older brother gave him 15 toy cars. Each month, he will add 7 toy cars to the collection. Write an equation that could be used to find y, the total number of toy cars in Jeremy's collection, after 4 months. So I'm going to be writing this one in y equals mx plus b form, where b is the constant, our starting value, and m is the rate of change, or what we add each time. So b, the constant, the starting value here would be those 15 toy cars he's going to start out with. And then the constant thing we're going to be adding is the 7 toy cars each month. So our rate of change is 7. So our equation would be y equals 7x plus 15. Okay, number 6 says which equation represents the linear relationship between the x values and the y values in the table. So I have y equals 3x minus 5, y equals negative x minus 8, and y equals negative 5x plus 3. So I just need to go through and figure out which equation, whenever I input x, is going to give me that output of y. So let's start with A. I am going to start with negative 1 for x and see if that gives me the output of negative 8. So we would do 3 times negative 1 minus 5. I just replaced x with negative 1. 3 times negative 1 is negative 3, and negative 5 is negative 8. So far this equation works. Okay, then the next point is 2, 1, so I'm going to replace x with 2 this time. So it'll be 3 times 2 minus 5, so that's 6 minus 5, which is 1. So the second point worked too. And then let's check the third point. I would do 3 times 5 minus 5. 3 times 5 is 15, 15 minus 5 is 10. So it works for the last ordered pair as well. So it looks like A is my correct equation here. I'm going to check the first point for equations B and C just to make sure that those don't work. So B is y equals negative x minus 8. Remember, that's really a negative 1 times x. So I'm going to check this first ordered pair. Negative 1 times negative 1 minus 8. Negative 1 times negative 1 is 1, and 1 minus 8 is negative 7, which doesn't match the output in the table of negative 8. So B is not going to work. Okay, let's make sure C doesn't work either. I'm going to replace x with negative 1, so it'll be negative 5 times negative 1 plus 3. Negative 5 times negative 1 is positive 5, and positive 5 plus 3 is positive 8, which doesn't match the output in the table of negative 8. So C does not work either. Okay, let's look at number 7. It says, which equation best represents the relationship between x and y in the graph? So there's a couple of different ways you can do this. If you want to find some ordered pairs from the graph and test out the points like we did with the table here and see which equation works, you could do that. Or you can use characteristics on the graph to help you match the equation. Remember, m is the rate of change. It's the change in y divided by the change in x. And b is the y-intercept. so where we're intersecting the y-axis. So let's see if I can find m and b from this graph and then match the equation to it. So m is my rate of change. I'm going to find 2 perfect points on my graph. I see one right there and one right here. And I'm going to count the change in the y's, which is the vertical change. It's 2 over the change in the x's, which is 3. So my rate of change is 2/3. So it either has to be B or C because those are the ones that have a rate of change of 2/3. And then B is the y-intercept, which is just where the line is crossing the y-axis, which is -2 for this line. So C is the equation that has that rate of change of 2/3 and crosses the y-axis at -2. Okay, let's look at number 8. It says, which relationship best represents the equation between x and y in the graph? So first thing I notice is my line is going down, so my rate of change is going to be negative. And I'm going to find 2 perfect points. I see one right here and one right here. And I'm going to count the rise, the change in the y's. It is 1, 2, 3. Over the change in the x's, which is 1. And -3 over 1 simplifies to -3. So it looks like it has to be A. Let's make sure I have that B, y-intercept at +4, which I do since it's intersecting the y-axis there. So the answer to this one is A.